So we have in 60, we have limit as x approaches 1 from sine x minus 1 over x squared plus x minus 2. We always plug it in to see what type of limit this is, or what type of indeterminate case it is. So where does the numerator go?
0.
Perfect. Where does the denominator go?
Also 0.
Very good. So all conditions for L'Hopital's rule are fulfilled. The limit, ratio 0 over 0. But I want to show the other method now. Can anyone factor this out for us? Because we know that there is a factor of x minus 1 in here. When we plug in 1 and we get 0, we know that one factor has to be x minus 1. And here I'm subtracting 1 from both sides. Or in other words, I move 1 to the other side. Good. Can anyone give us the second factor?
X plus 2.
Can we back up for a second? In the limit x minus 1, have we done anything like that before? Where we brought the number to the other side?
Oh, let's talk about it. If x approaches 1, can I say that x minus 1 approaches 0?
I guess so.
Right. So it doesn't matter. I can even subtract 10 from both sides. X minus 10 will definitely approach negative 9. I can add 10 to both sides. X plus 10 definitely approaches 11. Is this
our first time introducing that, though, that we can do that? Have we done that in other classes?
I'm not sure whether, but it's just a very good point. It's just common sense. If x approaches 1, then x minus 1 will approach 0. We did that when we did something like this when we looked at the slope of the secant line approaching the slope of the tangent line. So, but not with numbers per se.
Okay.
But it's like saying if x equals 1, will x minus 1 equal 0? Will x plus 10 equals 11? Will x minus 11 equal negative 10? They're all the same. The same with the equal symbol, the same with the inequality symbol, the same with the arrow. They're all the same concept. Is that better?
Yeah, so why are we, or maybe you're getting to that.
Yes, yes, right this moment, yes. So someone gave me the x plus 2. So remember a few minutes ago, we looked at this. As long as all these are identical, I can write that this limit is 1. And I see them here. The rectangle, the rectangle, the rectangle. They're all the same. So then where will this go?
To 1.
Yes, this will go to 1. But remember, x minus 1 approaches 0 is the same with x approaches 1. So this approaches 1. But the final answer will be
1 over x plus 2.
I'm applying the limit. Otherwise I have to copy the limit operator if I don't apply the limit.
So 1 over 3.
1 over 3 indeed. That's it. And we will obtain the same thing if we use L'Hopital's rule. Good. Anything else you would like to look at? Anything else? There is, we can look at other examples. There is one other, but there is, again, if we use L'Hopital's rule, we don't need to memorize this one. So there is one other limit, which is limit as x approaches 0 from cosine x minus 1 divided by x, which is 0. No need to memorize this one. We can always apply L'Hopital's rule and determine that. Again, for horizontal tangents, we know how to determine this. We find the derivative and set it equal to 0. We know that. Let's see if there is anything else that we would like to go through, or other limits. You want to choose another limit. This one is interesting. Let's take a look at 58. So in 58, let me copy it first. Limit as x approaches 0 from sine x squared divided by x. Okay. Well, we do not know. That's the next step. I'm going to start that section in a minute. But we don't know how to differentiate sine of a function yet. Sine of a function prime. We don't know how to do this yet. So I cannot really use at this point. We will in 10-15 minutes, but not right now. We cannot use L'Hopital's rule. It's obviously 0 over 0. Right. So then I want to think in these terms. Where is my page 11? I'm thinking of this again. But these three things have to be identical, right? But when I have x approaches 0, is it okay to consider that x squared approaches 0? It's like saying x equals 2. Can I say that x squared equals 4? Same thing. If x approaches 0, can I say that x squared approaches 0? Yes?
Yes.
Perfect. So then for now, I have the rectangle here and here, but I don't have it here. Well, I'm going to multiply by x, both the numerator and the denominator. If I do that, nothing changes. So then the limit now is like, I'm going to put this in parentheses. X approaches 0, but in parentheses, I know that even x squared approaches 0. The numerator is x sine x squared, and the denominator is x squared. I have the rectangle, and now I'm going to ask you, where does this go? Limit as x approaches 0, as x squared approaches 0 from sine x squared over x squared. Where will that go?
Is it at 1?
That's it. So this is 1, but now I still have a leftover. So what is the limit? What does the limit equal to?
0.
That's it. Well done. Thank you. Okay. Any questions? Any questions? Okay. I know I have like 12 minutes left, so I'd like to start. Which page am I on? I think I'm on 13, yes. Okay, 3.4, the quotient, the chain rule. Okay. The chain rule deals with a function composition. How do I get a function composition? When I have a function that is inside another function. So this is, the notation is f comp g. This is function composition. There is a function inside another function. This is the inner. This is the outer. Which function I apply first? G is applied to x first. Then when I get this answer from the inner function, then I apply the outer function. So if I want to evaluate f of g of 3, first I have to find g of 3. Let's say I get 10, and then I find f of 10. So the question is, how do I differentiate something like this? So f comma g prime of x prime is the outer function prime of g of x times the inner function prime. So a few minutes ago, 3-4 minutes ago, I said we don't know how to differentiate this sine of x squared. Let's do it right now. So I have sine of x squared prime. This is the outer, this is the inner. So I differentiate the outer function first. So when I differentiate sine, what do I get? Anyone? Very good. Cosine of x squared times the inner function prime. When I differentiate x squared, what do I get?
2x.
That's it. Yes, I will rearrange it, but this is it. That's it. Now, I would like to discuss something, a situation like this. Let's say I have x cubed plus 2x squared minus 4 raised to the 10th power. Which one is the inner? And I want to differentiate this. Which one is the inner function? And which one is the outer function?
The one in the parentheses is the inner function.
The inner function. So I have to differentiate the outer first. How do I differentiate something to the 10th power?
The 10 comes down, so it's...
And
10
whatever to the...
to the 9th.
Very good. So I'm going to copy it. X cubed plus 2x squared minus 4. So this is it so far. But now I have to multiply by the inner function prime. So can anyone tell us the inner function prime? I'm plugging my computer in.
3x squared.
Yes, 3x squared plus
4x.
that's it. Because the derivative of the constant will be
0.
that's it. So this is a combination, right? We have a power rule with a function. So bring the power in front, subtract 1 from the power, copy what I have, and no, don't even try to simplify this. No one will ask you to simplify something like this. Times the inner function prime based on the quotient, the chain rule. Now, what I would like us to remember is something like this. When I differentiate, so I think it's 14. When I differentiate a function that has the square root on top of it, can anyone give us an idea? We know the rule for differentiating the square root. What is the rule for differentiating the square root? We already used that a couple of times tonight, or at least once.
So 2 times...
Careful, 1 over 2 the square root of this, whatever that is, times the inner function prime. So now let's choose as many as we need to practice the chain rule. Anything you want. From 7 to pages and pages and pages and pages. Okay, you choose.
Can I see like the around 50? Yeah, the number 50.
50, 50?
Yeah.
Perfect, let's copy it and then I'll stop sharing. So we have y equals sine of theta plus tangent of theta plus cosine theta. Perfect. Good pick. Thank you. Okay. Let me start a new video because I got